In this lesson, we are now talking about higher order derivatives. So like, for example, what we focused on is just the first derivative, like with our notations here. So here you're given the function f of x, our original function, and we have been finding the first derivative, right? So, and here's our different notation. So literally a higher order derivative is going beyond the first derivative. So like the second derivative. Notice how the notation here just is pretty much that same situation, just showing now instead of like the 1, now we've got 2. So basically, again, 2, right? The second derivative is you're just taking the derivative of the first derivative. So same thing here. If I want to know what is the third, oops, that's a typo. If I want to know what's the third derivative, then you take the derivative of the second derivative, and so on and so forth. So like, let's just say, for example, the derivative, we are given the function, so f of x is equal to, let's say, 2x to the 7, all right? So then the first derivative, which is what we're used to, so we would take the derivative, which is 14x to the 6, right? Our power rule, bring down, multiply here by that constant multiple, our coefficient, subtract 1 to get 6. So then the second derivative would now be just multiply again. So now this is 84, x to the 5th. Then same thing here. What is the third derivative? So then again, now here we would multiply 84 times 5, which is, I believe, 420, x to the 4th, and then just keep on going. So this is our higher order derivatives, where you start with the original, just keep on going, and that's our higher order. So like here, just to practice, and it's the same rules. So like here, if we're just adding and subtracting and we're finding the higher order derivatives of these functions, so again, we're going to take each of our terms one at a time that's being separated by our addition and subtraction. So the first derivative here, right, see our marking, so this would be 12x squared, so again, our power rule, minus 12x, right, so again, multiplying here, plus 1, right, because what's the derivative of our constant? 0, it goes away. Remember here, we're just taking that coefficient of x, which is just 1. So now we're going to go ahead and get the second derivative, right? Notice our notation. So here we go. This is 24. Oops, sorry. 24x. Sorry, my pen is there. We go. 24x, right? Because then subtract 1. Minus 12, right? Take the coefficient here. And then that's it, because derivative of our constant is 0. So now we're going to find the third derivative, which is here, 24. And then that's it, because derivative of a constant is 0. So then if I wanted to know what is the fourth derivative, well, what is the fourth derivative? 0, because it's just a constant. Derivative of 24 is 0. So then here, if you need to rewrite this, right? This is 1 over x, just like before. So we're starting with x to the negative 1. So here we go. Derivative is negative 1, then over x squared, right? Because this is bring down and subtract 1. So this is like negative 1 times x to the negative 2. Keep that in mind. So then for the second derivative, right? So here we go. This is now a positive 2 over now x to the third, right? Because again, subtract 1. So this is 2x to the negative third. So then same thing here, the third derivative, right? So we're going to multiply. So now this is negative 6 over x to the fourth, or negative 6 times x to the negative 4, right? Because it's in our denominator. So then what is our fourth derivative? So notice here, positive 24 over x to the 5th. And I won't rewrite it because we're not doing another derivative. But if we wanted to, we could rewrite to continue on. So again, notice It's just higher order. Just keep on with the derivative, building one on the other. So go ahead and pause the video and do these two U-tries on your own. And here we go. So if I just want to know what is the third derivative, so we're going to stop after the third, right? So here we go. For the first derivative, you should have gotten 8x to the third minus 6x. Then for the second derivative, we're going to continue here, right? So 24x squared minus 6. So then for the third derivative, your final answer, the third derivative is 48x. That's it. Because remember, right, derivative of a constant is 0. And then subtracting 1, so that's why it's just 48x. Now here, if we want to know, notice from the notation, we're trying to get to the third derivative. So here we go, if you need to rewrite it. So this is x to the negative 3. So the derivative of our original is negative 3 over x to the fourth, right? Because that's negative 1. So now if you think about it, right, if we're trying to get to the negative, you don't have to write it as a fraction. You could keep it in this form so that if it helps you with your calculation. So here, like let's go to our second derivative. So the second derivative is now positive 12, right? Negative 4 times negative 3 times x to the negative 5, right? From subtracting 1. So then the third derivative, our final here, is negative 60 from negative 5 times 12 over x to the 6, because this subtract 1 is negative 6. So that is the third derivative. So now here, what if we've got our composite? So we still need to follow chain rule. So like, for example, if I want to know, right, just what is the derivative? Well, here we go. Well, what is the derivative? Anytime we had e, like e to the x, well, it's just e to the x, or e in this case to the negative 2x. Then times now the derivative of the inside function, which is negative 2. So now rewrite this because this is going to be key. This is negative 2 times e to the negative 2x. So that is the first derivative, right? Just move your coefficient so that it's out in front. So now here we go. The second derivative. So again, here this is negative 2. So negative 2 times e to the negative 2x, right? Because again, e to the x is still e to the x. Then times the derivative again of the inside function, which is still negative 2x. So multiply here by negative 2. So notice now here you've got negative 2 times negative 2, which is positive 4. E to the negative 2x. That is the second derivative. So then here, the first derivative. Well, here, notice how our exponents are outside functions, so we would bring down power rule. So here I've got 2 times sine of x, then times. Now the derivative of the inside function, which is cosine x. So now we're going to have to find the derivative of this function. But notice we've got product rule. So we've got to find the derivative of the first times the second. So derivative is 2 times cosine x times cosine x. Then we add to that, right? Now the derivative of the second times the first. So derivative of cosine is negative sine x times 2 sine x. So now let's rewrite this. Notice how I've got cosine times cosine. So that's 2 times cosine squared x. Then minus from our negative here, that is 2, then again sine times sine. So 2 times sine squared x. That is the second derivative. Just notice here, you had to apply product rule. So now our last one, here we go. So we've got our power rule. So we're going to bring down here, right, because this is our outside. So 4 times 3/4 x minus 6, right? Bring this down, but now raise to the third power, right? Subtract 1. Now multiply that by the derivative of the inside function. Well, that's just 3/4. Because here, remember, right, derivative of -6 is just 0. So now notice we can simplify because that's 4 times 3/4. So notice how 4 divided by 4 is 1. So really, this is just 3 times 3/4 x minus 6 to the third power from simplifying. Now we can find the second derivative. Power rule again, right? So now 3 times 3 is 9 times 3/4 x minus 6, but now raised to the second power. Then times the derivative of the inside, which is 3/4. Now, we cannot simplify 9 times 3/4 like before, right? Because 9 divided by 4, you can't simplify. So this is our derivative. Or if you really wanted to take it a step further, 27/4 times 3/4 x minus 6 to the second power. So go ahead and pause the video and try the 2 U tries here on your own. And here we go. So we're going to focus on the second derivative. So the first derivative, well, again, outside, so cosine is negative sine of 2x, right? So bring down that original inside function, like our g. Then times now the derivative of the inside, which is 2. Now we're going to take the derivative of the second derivative. So here we go. Now keep in mind, this is -2 times sine of 2x, right? Bringing our 2 here out in front, our coefficient. So again, derivative now of sine is cosine. So -2 times cosine of 2x, right? Bring down the 2x times the derivative of the inside, which is 2. Now, if we want to fully simplify, this is -4 times cosine of 2x. So now here, we're going to take and get to the second derivative. So our derivative here is, remember, right, e, so it's still e to the 3x plus 1. Then times, now the derivative of the inside function, well, that's just 3. So again, if you wanted to bring that in front, that's 3 times e to the 3x plus 1. That is the first derivative. So now the second derivative. So again, that's 3 times e. So again, this is 3 times e to the 3x plus 1, right? E to the x, still e to the x. Then times, again, the derivative of the inside function, which is 3. Notice we've got 3 times 3, 9, e to the 3x plus 1. That is the second derivative. So now last type of problem is what if we have to evaluate? Notice how this is not just saying g of x or, g in the derivative of x. So we are going to find the value when x is 2, but for the third derivative. So here we go. Our first derivative is -4p to the third plus 6p squared plus 1, right? So again, power rule, bring down, subtract 1, bring down, multiply here, subtract 1, derivative of a constant is 0. So now the second derivative is -12p squared plus 12p. And then remember, right, derivative 0. So now the third derivative, this is what we're looking for, is -24t plus 12, plus 12. So now here we go. We can find our value at 2. So t, or x, yep, so t is 2. So our value here is -24 times t, which is 2, plus 12. So now I've got negative 48 plus 12. So our third derivative, right, when p is 2 is equal to negative 36. That is the output. Go ahead and pause the video and try the U-try on your own. And here we go. So notice how here you needed the second derivative to find when x is 1, what is the output? So here our first derivative is 4x cubed minus 3x squared plus 2. Then our second derivative is 12x squared minus 6x, right? Because derivative constant is 0. So here we go. Now we can find when the x is 1. So x is 1. So this is equal to 12 times 1 squared minus 6 times 1. So here, remember, right, this is like order of operations. That is 1 squared, which is 1. So 12 times 1 is 12, minus 6. So our output is 6.